use a greenfield vector database or an existing vector database?
Johnny, what do you think I'm going to say? Here's the funny part. Like, why are people throwing out the baby with the bathwater? Why are they trying to use these new systems from scratch that are not reliable, don't support SQL, like variants?
What if I'm a customer with an unstructured data like I want to go for a greenfield vector database?
Come on, Johnny. That's a softball. That's a softball. Okay. Two things.
What's your view on Supabase and how do you compare and contrast with Timescale?
Is built a really great Firebase-like experience around Postgres. They don't do much inside Postgres.
So much of buzz around agents and agentic workflows. Is that really a hype?
This is a great question. We don't get the hype. It sounds very science fiction-y cool. Timescale is the classic solve your own problem, scratch your own itch story.
Hi Ajay, it's great to have you on my show. Welcome.
Johnny, thank you for having me.
Awesome. So I've been tracking Timescale for a long time. Could you give us a bit of background on how Timescale evolved and how you went about building Timescale as a company?
100%. Timescale is the classic, solve your own problem, scratch your own itch story. We started off several years ago. Roughly 2017 is when we launched. Initially as a database for IoT data, and it's because we were working in an IoT company, and we needed a better database. It didn't exist. We built it, and then we launched it, and that became the main product in the main company. Soon we realized by listening to the market, our users, and soon customers that more than IoT, it was a time series problem, which is IoT, maybe finance, crypto, some other areas. And then over time, we saw that companies were spending more money on us than we expected, and we realized they were using us as their main application database. And we realized the story here wasn't just time series; it was Postgres, and it was really Postgres for real-time analytical applications. And now, as you can probably tell, with the rise of Gen AI, vector is now part of the story, but it's still these same kind of data-heavy applications that we're serving. So, where we are today is, hey, Timescale is really Postgres made powerful, another way is it's really it's Postgres reinvented for data-heavy applications, and now that includes time series, real-time analytics, vector, embedding management, and of course, traditional OLTP CRUD.
Awesome. So Postgres is already pretty flexible, and you seem to be embracing and extending the core engine. So how do you go about making Postgres more accessible, flexible, and more customized for the use cases that you mentioned?
Yes. So a couple things. Postgres is wonderful. We love Postgres. One of our common sayings internally and externally is, Postgres for everything. Just use Postgres. All you need is Postgres. And why all this Postgres love? It's really because it's really a love for simplicity, right, and reliability, and it's the idea that as software applications get more and more complex, as data is flooding the world, as your data pipelines get more and more, intricate, complicated. It actually gets harder to actually build the application, to build the thing that you wanted to build. And so, we believe that the answer to all this isn't more complexity; it's actually simplicity. Is boring. You want your infrastructure to actually be boring because you just want it to just work. Boring is awesome, and so it's Postgres for everything. That is the fundamental. Now, the challenges with Postgres is that it was designed, initially built, 30, 40 years ago. It is primarily designed as a really rock solid database for OLTP. It's quite versatile for OLTP. It's quite reliable, but that's what it's designed for. And the traditional concerns we hear about Postgres is like, yeah, but it can't scale. Yeah, but it's not modern. Yeah, it's not cloud native. And what we've essentially done is solve those problems. And what we said is we can make it scale. It's not impossible to scale. It's hard. We can make it scale. Uh, it doesn't have a columnar storage. We can build columnar storage. It doesn't it doesn't have actually PG vector added vector support soon. But it's like, look, we can make these things work even better. We can give you a modern architecture with decoupled compute and storage, with data sitting in both disk and S3, and a really modern architecture. Uh, so the question is how, right? What's the secret? There's no real secret to it. The basic idea is, um, okay. There are two ideas, right? Well, the first idea is, if you want to solve a problem and your current tool doesn't work, do you reinvent a new tool from scratch, or do you make the current tool better? And most developers, not most, a lot of developers, especially in the 2010, 2015 range, right? In that time period, 2005, 2015, it was really fashionable to say, no, these old models don't work. SQL doesn't work. No SQL, and what people soon realized is, wait, like, we're throwing away the proverbial baby with the bathwater. We're throwing away all the good stuff that made these relational databases work. Uh, and our insight was like, hey, you already have this thing that is phenomenal. Why not just make it better, right? Well, the reason why people didn't make it better is because it was hard. But what we realized is that Postgres had this extension framework. It essentially had a set of APIs that allow you to hook really deeply into the Postgres, the query planner, into query execution, and of course you can create new data types and all that as well. And what we realized, what the team realized, I should say, is we this extension framework allows you a super powerful way to make Postgres better, and that's what we did. And I would argue that we are the most complex Postgres extension, uh, I think, ever. I think we push it to the limits. Um, Yeah, but I mean, I think where we ended up is, hey, we can actually make Postgres scale by taking advantage of Postgres' natural extension framework, and also taking advantage of some smart architectures in the cloud. And um, and boring is awesome. Now you have this thing that you already loved, and it's even better.
Excellent. So, switching gears, let me talk to you about the landscape. One entity that's gaining a lot of attention is Supabase.
Hmm.
Developers seem to love that, and interestingly, that's also built on PostgreSQL. They do object storage. They do a variety of other, Firebase equivalent capabilities on top of Postgres. So, what's your view on Supabase, and how do you compare and contrast with Timescale?
Yeah, they're very different products. I think serving different markets. I like Supabase, super fun company, super fun brand. We have friends who work over there. Um, I know Paul, the CEO. I think it's a fun company. We're going after two different parts of the market. And uh, what we say at Timescale is we go after data heavy applications. So these are applications for example, in the industrial sector, energy, manufacturing, transportation, logistics, agriculture, automotive, but also in the digital native areas, finance, fintech, crypto, gaming, e-commerce, social media. And we really deal with applications where a terabyte is not a lot of data. As Supabase is the other end of the spectrum. Supabase is, number one, it is a better Firebase, and what they've essentially done is built a really great Firebase-like experience around Postgres. They don't do much inside Postgres. Like all of our innovations, most of our innovations are inside Postgres. Most of our innovations are outside the database. Even their object storage it's more about being able to access data and object storage from the database, versus what we've done is have hyper tables that span disk and storage, so it's entirely transparent too. So it's a very different thing. Uh, I mean, I think what they're doing is perfect for their market. Um, but yeah, it's a totally different product. It's really a Firebase built around Postgres. I really love the work they're doing, and I would say I would say their largest customers are probably some of our smallest customers in terms of data volume. They have uh, they have a lot of excitement in the JavaScript community. I think it's really cool, and I wish them luck. I think it's a really big market, and I'm really excited to see all the innovation that that that's coming up.
Nice, nice. Now, continuing on the landscape, uh, today the vector database market can be categorized into two. One is greenfield vector DB companies, like ChromaDB or Zilis or Milvus. These are you know vector first databases, and then we have traditional databases like Timescale that also support vectorization or storing embeddings. Now the dilemma that customers have is, should I use a greenfield vector database, or should I use like an existing vector database built on top of an OLTP engine or something that's already existing, an incumbent player? What is your suggestion to customers who are making a decision on choosing the right vector storage engine?
Johnny, what do you think I'm going to say?
I know the answer. I know the answer, uh, but I
I
want to
mean,
hear from you.
here's the funny part. The funny part is this whole journey we went through with Time Series 7 years ago, which is that, hey, like, why are people throwing out the baby with the bathwater? Why are they trying to use these new systems from scratch that are not reliable, don't support SQL, or weird SQL like variants, and you have to run them alongside Postgres anyway? Why not just use Postgres? And it's literally the same movie we're seeing again with vector databases. People are like, "Oh yeah, you should use Pinecone or Chroma, alongside Postgres." And we're like, why not just use Postgres? Like, why add this complexity? And they'll be like, oh, performance. We're like, no, here are the benchmarks. It's not purpose built. Yes, it is. We have customers with billions of embeddings on Timescale. Using PG Vector, PG Vector Scale, which is our product, open source. PGAI Vectorizer, also our product, open source. And yeah, man, like, I mean, here's the thing, Johnny. Like, if you're building an application, let's say this application, it's customer facing, it has dashboards, it has, maybe some type of maybe chat interface, so it has some Gen AI, vector database behind it, right? Either you're going to have Postgres plus ClickHouse plus Pinecone, with all the plumbing around it, and by the way, you know, Postgres is full SQL. ClickHouse is SQL-ish, but a lot of things you can't do. And Pinecone is not SQL, right? And no, by the way, it's like, hey, there's a problem with Pinecone. Who's our Pinecone expert? Oh, we're running the issues with ClickHouse. Oh, what's our ClickHouse expert knowledge base? Oh, we retrain the whole staff, right? That's option one. Option two is Postgres, 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 right?
Yeah, but
And the trick is, I'm sorry, the trick is, and people are like, no, is this too good to be true? No, it's not too good to be true. The challenge with Postgres is that getting it to scale is hard. It is hard, but we do the hard things so that you have an easy experience.
Ajay, I have a slightly different view. Now, what if I'm a
Yeah.
customer with 5 terabytes of PDFs and unstructured data lying around on my object storage or data lake, and I have no investment in PGSQL, and I want to go for a greenfield vector database because I believe that is better suited for building a pipeline to convert unstructured data into vectorized embeddings and store them and query them.
Oh, I mean, come on, Johnny. That's a softball. That's a softball. Okay. Two things. Two things, right? First is our product Vectorizer. What does Vectorizer do? Vectorizer inside the database does embedding management. So as your data changes, it'll automatically update the embeddings as a result. As new data comes in, it's very transparent. One of the things the team is working on this quarter is Vectorizer on top of S3 buckets.
Oh,
Done.
nice.
First done. Right. Okay. Right. Another trend we are seeing is a lot of data. We do tiered storage, which is allows you to store raw data um, in S3, and then store aggregates, in the database itself. Right. Some people call this the medallion architecture. I think Databricks might have come up with that, but it's right. We see that trend as well, right? And we already have the ability to store your data in S3 and have some type of aggregation of it or projection of it, inside the database, right? Um, there's some efforts actually to make Postgres, and this is actually a really exciting area for us that we have like an R&D team focused on. This is one of my co-founder, my CTO, is one of his key efforts. Really awesome effort that essentially positions Postgres, really Timescale, as the operational serving layer on top of your data lake.
Hmm.
And
Interesting.
yeah, it is interesting, right? And the whole point is that like you're like, oh yeah, but you have to build something new from scratch. No, you don't. You don't. And it's better if you didn't, right? It's like, wouldn't you rather use the database engine that's been battle tested for 30 years, used by millions of companies in production? Okay, maybe not millions, but a lot, maybe hundreds of thousands of companies in production worldwide, right? Might be millions. Um, or would you rather use the database that was founded 2 years ago with a team of 25 people or 100 people, right? That you know what I mean? I mean, and I'm not saying this. I mean, it is funny, but I'm not trying to be funny. I'm just trying to be like, why is this even a question?
Very compelling pitch. Very compelling pitch. I completely agree. Uh, so you mentioned two products. One is
Yeah.
PGAI, the other one is PG Vector Scale. So what exactly are those, and what is the difference?
A great question. So first, they are both open source, fully open source Postgres licensed Postgres extensions, and they're Postgres extensions primarily designed for vector slash Gen AI or type workloads. Um, First one, PG Vector Scale, essentially improves on limits of PG Vector. What's PG Vector? PG Vector is an open source project developed by an individual named Andrew Kane that essentially adds support for embeddings, vector search, semantic search inside of Postgres. It's really great. There's some performance limitations with PG Vector, and we actually initially offered to what do you call it? Contribute them to PG Vector, and Andrew was like, you know what? Why don't you create your own extension, because that way, you can do your own thing and you don't have to do super be coordinated. So with his blessing, we created PG Vector Scale, which essentially builds on PG Vector and scales it to millions and really billions of embeddings, and performance that beats Pinecone, Chroma, whatever. That's
Hmm.
one. Yeah. The second thing is PGAI. PGAI is a collection of other tools for Gen AI. One, and the most popular one right now, is called Vectorizer, which is embedding management. We just talked about that earlier. The other one is that we haven't launched yet, but it's in our GitHub repo, so you can check it out if you want, but we haven't fully announced it, is text to SQL, which is the idea of converting natural language to SQL. And you might ask, oh, is that really for developers? It's like, no, it's actually for the LLM. It's still to allow the LLM to actually query structured data in the same way it uses vector search to query unstructured data. So those are the two projects. PG Vector scales PG Vector, and then PGAI is a collection of tools for Gen AI workloads, including embedding management and really RAG on top of structured data.
Very interesting. So you have contributions to open source and you have a commercial model. So what is the business model? And do you support on-prem deployment of Timescale?
100% we do. We have three deployment models. First is open source. Here you go, run it yourself, run it wherever you want. It's people use in production. It's rock solid. Uh, then we have managed cloud, which is, hey, we'll manage it for you. There's some features that are enabled in the managed service that is not on self-managed, because it's not really. It's easy for us to do when we manage the whole environment. It's hard for us to do when we don't. So data tiering, decoupled compute and storage. We have native integration with Popsicle, which is our UI tool. Quite a few things in the managed cloud. And the third deployment option is BYOC. And so, bring your own cloud account. And in that case, we will, support the instance installation for you. We are not operating it day to day, but we are supporting it for you. And for some of our larger companies who need it on their own infrastructure for obvious reasons, that's a popular deployment. So there are three models: open source, cloud, managed cloud, and then BYOC.
Awesome. And finally, with so much of buzz around agents and agentic workflows, what is your view and how do you think Timescale is going to support? I know the answer, but is that really a hype, or are agentic workflows going to replace enterprise application integration and existing business processes?
This is a great question, and I'm actually curious, Johnny. What do you think I'm going to say? Because I'm not sure. Yeah.
Yeah. So what I'm actually saying is, traditionally we have seen systems of engagement and then systems of record where typically PostgreSQL fits in. Now I'm actually envisaging a new layer which I call as systems of intelligence, and that's where agents will sit. That's the new middleware which will orchestrate business processes and also work with the systems of engagement layer and systems of record to basically make sure it closes the loop.
I think there are two questions. There's the if and the when, right? On the if, yeah, I agree with all the Asian hype. I think at some over some time period, we will have hopefully autonomous agents doing work for us, so we can do higher level work, right? Um, I don't think that's happening anytime soon. Or at the very least, what I'm seeing and what I'm hearing is for simple tasks, yeah, it's there today, but the more complex it gets, it's going to be a while. There's also, man, there's so much, current built-in workflows that would totally have to change. So my take on agents is what we like to say internally at Timescale is we don't get the hype. We don't get it, you know, because it sounds very science fiction-y cool. Yeah, great. Let's have some beers. Let's have coffee. Let's talk about what the world might be when enterprise SaaS doesn't exist and everything's an agent. That's really cool. Uh, I do think it's cool. But I think that it'll take us like a little bit longer to get there than people think. There's going to be a transition period. I mean, look, driverless cars, right? If you're in San Francisco, you see Waymos. If you're other parts of the world, you might see other cars. Driverless cars, they look like a car with a steering wheel, and there's two seats in the front, two seats in the back. And you might say, why? Why isn't this thing totally redesigned, right? Why isn't that totally redesigned? And like, you don't need the steering wheel. Maybe you just need the seats in the back. And by the way, the road should look different, right? Because they're driverless. Everything should be different. And you're like, yeah, eventually we'll get there. But like, there is a transition period that people I think overlook, and there's a variety of reasons. With the case of cars, safety is obviously a big concern, but there's also like just like as people, like there's a little bit of a sticker shock where you're just like, wait, not sticker shock. There's a bit of shock where you're like, hey, wait, what is this thing? And driverless cars, because it looks like a normal car, it gets over that. My point is, for the same reason that driverless cars today look like cars and they're driving in the same roads that cars on, I think the first set of agents are not going to be the thing that completely replaces SaaS, right? But
Hmm.
eventually it will. And what's the phrase? Progress takes a long time, and then it happens overnight, right? So at some point we'll hit the elbow in the inflection curve. We're like, whoa, how did we get here? That's how I think how we feel right now with LLMs, right? And I think with agents, I think it'll be a lot of hype, some early successes, but I think it'll be several years before we hit the inflection point. I don't know. Maybe we can have
Agree.
this conversation again in 10 years, and then we can see what I got right, what I got wrong. But I'm thinking it's probably some time frame like that. But when it happens,
Perfect.
holy cow, it'll be like, oh my god, like how do we get here so fast? Yeah.
Yeah, very, very exciting future. So, well, that brings us to the end of this discussion. Ajay, thanks so much for joining me. I thoroughly enjoyed the conversation, getting your perspectives, and I'm sure my audiences would love this show.
Johnny, I really
Thank you.
appreciate the time. Thank you for making the time. Thank you for having me.